So the second objective, which says to calculate antiderivatives of functions given on the first column of page 345, are right here written on the board. This column right here, those, and these two are the basic, we call them toolbox kind of functions that we're going to take the antiderivatives of. And I think the best way to learn this is to do examples. So for example, our first one is c f of x. So I just gave the example 2x. In order to take the antiderivative of this, or the integral, is I'm going to put the integral sign and also d of x, because that's the value we're evaluating. And then you just take x, and so imagine there's a 1 there, and you add 1, and so this equals 2 now, and you're going to divide by that same number. So it comes out to be 2x squared over 2, and then our 2's will cancel out, so we're just left with x squared. Okay? Next one is the same idea. I'm going to do the same thing with the exponents, but I'm just going to add them together if possible, and if not, then they're just going to stay as is. So the integral of this is going to be 3x squared plus 8x divided by 8x cubed, rather, divided by 3. And since obviously these two don't have the same exponents, we can't add them together, so it's going to stay as is. Next one is very similar to the first one. It's going to be x to the 4th, so we're going to add 1 to that. So it's going to be x to the 5th, and then don't forget to divide by that value, so divided by 5. This one, 1 over x, the integral of that is just the absolute value, or natural log absolute value of x. And then we have e of x, and it's just kind of like derivatives where it's going to be exactly the same. And so in this case, it's still just e to the x. Now one thing I didn't include here that actually does go with integrals is the plus c. So the plus c is a kind of constant that we're not sure of right now, and in other equations we'll be able to solve for c, but right now it's not all that important, but it is important to include when you do take the integral. And finally, we've got our trigonometric functions. So we've got cosine of x, so I'm going to take the integral of cosine of x. Okay, so you remember the derivative of cosine of x is negative sine x. So if this would normally give you a negative, but since we're doing the opposite, this is actually just going to give you sine of x. And it's the same, it's opposite again for sine. So normally the derivative would just be cosine, but since it's positive and it's like you're trying to go back to the cosine, it's going to be the opposite, so it's going to be negative sine of x. And that's our second objective.